A question has come up about how to constrain this thing, and I can see where some confusion may come in, um, especially if you've never messed with any angle vices before in your life. There is a 3D printed model in the lab. If you would like to take a look at it, it's close to being fully functioning. Um, the movements are there. It's assembled, with the exception of the locking levers. I don't think are installed on it, simply because the little handles break so easily. But you can certainly handle it and kind of move it around a little bit and see how the thing operates. As far as assembling it, use your axes and your planes, your XYZ planes, as much as you can. Okay. Of course, that depends on how you created your parts. All right. Uh, Excuse me there. Got my email open. um, Depends on how you assembled your parts. So when you bring in part number one, make sure it is grounded so that it doesn't move. And then part number two moves in this direction like this. Okay. Now, if we're not planning to animate this thing, but if we were to animate it, or if we wanted to run, different analysis and things on it, then we would certainly constrain that with limits so that it could move, the length of the slot. But we're not going to do that. We're going to constrain it so it is totally locked down. And so to constrain this one, you can use a tangent made on the two surfaces, the two curved surfaces, that keeps them in contact with each other. You can use a axial mate constraint on the center of the two arcs. Okay. Different planes, things like that, and then you can establish. Excuse me. I established an angle constraint. That's part number three. I established an angle constraint to keep it locked in place like that. Okay. Okay. And so the same thing for part number three here. It slides like so. Okay. Very, very similar constraints on both of those. The top part right here fits down in that hole and then spins. Okay. So pick a direction, this direction, pick a direction and then lock it in place so that once you create your drawings, and actually, I don't know, I don't care which way you constrain it. In this direction would be fine since we got 0 marks there, or a 0 mark on this end. Either way, pick a direction and constrain it there so it's locked down at right angles. These set screws here at the top, these 4, pick a uniform distance that you've inserted it, and then lock it in place. Okay. These right here, I showed you in another video how it presses against the brass plug that's on the inside. So the depth of it will be set by that brass plug, and the plug being tangent against this part. Excuse me. Had a hiccup. So the depth of that will stick out a little bit. The little eccentrics right here, of course, they get inserted into the hole, the larger diameter, and rotate them so that they're not touching the top and bottom. And I saved a little time on assembling this, as I made a sub-assembly of the eccentric, the handle, and the drive pin. And so I put one in my assembly just to see what orientation the eccentric needs to have, so that when it's inserted, it's not really touching top or bottom, and then put my handle on it, and get it lined up. I did it as a sub-assembly, seemed to work out okay for me. You can certainly try that however you choose. Trying to think what else. All of your fasteners need to be constrained so they don't move. Some of mine are at this point, some of mine are not at this point. But yeah, they do all need to be constrained, because once you start creating your presentation file, you do not want anything in your assembly to be moving, should you come back and touch something later. So make sure everything is constrained in place. You can check yourself by going to the View tab and turn on Degrees of Freedom, and you'll get the little pop-ups of everything that is not yet fully constrained, and that'll give you an idea of what you need to do. Okay. And geez, I'll tell you a way, and it's kind of confusing, a way that I use to check things sometimes, is I'll change my visual style over to wireframe, and I have to know exactly what I'm looking for. But if I look at my screws, okay, so I've got the red outline here is the drilled hole, and here's the cap screw, or the fillet head screw that fits in there, the fillister. And what I'm looking at is to make sure that the head of the screw is not too far into the counterbore. Okay, I'm looking to make sure it's aligned with the hole. And then if I select the screw, you can see the bottom of the head is constrained to the bottom of the counterbore. Okay, so that's one thing I'm looking at in that case. It just gives you an idea on how you can look at things. And it does get confusing when you're in wireframe mode. Same way with the drill pins. So here I've got a drill pin right here and the hole for it. Okay, so there's the drill pin, and I've got it constrained flush on the outside. Let me rotate it back around. Flush on the outside, and you can see there's a little bit of space left at the bottom of the hole. So that's another way of looking for things, okay? And yes, it is confusing. Like I said, if you got questions, come look at the example in the lab. Send me an email. We can get on WebEx. I'll be around, since this project goes over spring break. I will be around during spring break. I will not be working every day. But if you send me an email, we can make an appointment to get together to answer your questions. Okay.